Very good day to you all. My name is S.Adebayo. We are taking the week 2 of mathematics, and we shall continue from where we stopped in our last class. Last class we discussed basically mean, mode, and median as a measure of certain tendencies, and how do we calculate some basic form whenever we are given rather mean, mode, and median questions. This task we shall continue with when we have a complex situations, especially when we have a group data. How do you calculate the mean, mode, and median for the group data? Now, in the mean section, mean for group data can be defined in or calculated in two ways. The first one is this: when we have S equals to summation of fx over summation of f. And the second one is when we have an assumed mean. In most cases, they can give you that you should assume the mean to be something, and that is the mean is calculated using the assumed mean to be a plus afd over, that is summation of fd over summation of f. Don't forget the d is called deviation, and that is deviation from the mean, and it is x minus the assumed mean. We shall talk about that later. So these are the two formula for calculating the mean. Is that you are having the summation of fx over summation of f when the assuming is not given, and whenever the assuming is given, you get the mean to be assuming plus the summation of fd over summation of f, in which d is the deviation from the mean, which means x minus a. So then we shall go to the next one, work examples about this. Look at this question. The weight of to the nearest kilogram of a group of 50 students in a college of technology are given below. That's weight of the 50. The question says prepare a table, group frequency table, and they have given us the class interval 45 to 49. That's the class without the method of assumed. Calculate the mean. So that means we are not going to use the assumed mean method because we calculate the mean of this distribution. And the third one is that we now use the assumed mean of 62. So the third one is we use the assumed mean method. Second one, we use the method of non-assumed mean. This is a wide question anyway. Now let's look at the question very well. We look at the data. We now want to group the data, make a table. By the time we make the table looks like the one we have under A. From 45 to 49, we have 9 of them. By the time you count each of these data, you can write this one down in your notes and practice. We have this one to be 45 to 49, we have 6, 50 to 54, we have 9, 55 to 59, we have 10, 60 to 64, we have 12, 65 to 69, we have 7, 70 to 74, we have 6. You can see that. So by the time you put that in the consideration, the question says we should calculate the table. That's the table. The first one, prepare a group table, frequency table with the class interval. Now, without the assumed method, you also now calculate the mean. Now, if you want to calculate the mean, the mean is summation of AFs. You can say, let's look at the table below before the B. Look at the table. The class interval, look at this table. The class interval is this. The class mark is this. That is, your class mark is that you are going to get the average. That is 49 plus 47 over 2. You get this one. 54 plus 50 over 2. You get this one. That is the class mark. Whenever you have the interval like this, you get the class mark. Now, the frequency, which is here, is here. And the fx, don't forget, you are going to get here, which is the frequency by the class mark. So 46 by 6 here. We have 52 by 9 here. 57 by 10 we have here. And that's so when we add everything here together, some frequencies give us 50. When we add the summation of fx together, it gives us 2,965. So the mean now equals to summation of fx, which is 2,965, over the summation of f, which is 50. That's exactly what we have this one to one decimal place. And that is according to the question. The question says to one decimal place. Don't forget, all these things are carry marks to one decimal place. Now, the second one is using the assuming method. They gave us assuming of 62. A 62. So the class interval is the class interval here. This is the class mark. This is the frequency. This is the deviation, and this is FD. This is one cut when I was comparing. This is FD. This is FD column. Now let's look at this together. We know this. Let's go at D. D equals to x minus a. That means they have given us a to be 62. So you now go and be subtracting 47 minus 62. It gives us minus 15. X minus a. 52 minus assuming given. So you get a deviation column. Whenever you have assuming method, there's a deviation column. So now we now have frequency by deviation. This is FD. That is the 6 by minus 15 minus 90, 9 by FD. This is FD column. Are we together? Okay. If you look at this now, this is FD. This is FD column. This is D column. This is the frequency. And this is so now we are given when we add these things together, it gives us okay, it's not that it gives us some so the yes, it gives us minus 135. So the using the assuming method, you have mean equals to assuming plus summation of all this is summation of FD over summation of F, and our F is this. Our summation of F is minus 135. So that's why we have 62 here. That is assuming, which is 62 plus 1 minus 135. That is FD summation of over summation of D, which is 50. So by the time you get your answer, you get our answer to be 59.3 to one decimal place, which is the same thing as what we get here as well, 59.3. So that is using the assuming method. So these are the two ways by which you can ask you to find the mean. So that they use it as the assuming method, which is that one you are going to use formula of A plus EFD over EF. If you are not giving using method, you use normal EFX over EF as a. So now this is the class activity that I want to. This is a NECO pass question, which is somehow similar to what we have there. I want you to try and do this one inside your notes, and let's see if you have any issue with them. Let me know. Now let's look at the median of the group data. When we have median, the median of the group data is given out by the formula. You have this is the formula for median, and that is, formula is L1. That's a L1 plus open brackets n over 2 minus CFB close over FM close bracket. See, let me explain to you what each of these terms represent. The L1 is lower class boundary of the median class, because we are definitely going to look at what is the median class. So the lower class boundary of the median class is the L1. The N here represent the number or total frequency, the total frequency of that particular distribution. The CFB is cumulative frequency before the median class. Cumulative frequency before the median class. And FM is the frequency of the median. This is the frequency of the median class. This is the FM, frequency of the median class. And the C is the class interval or class boundary. Let's look at that again. All these formulas must be in your fingertips. Now look at this example. The table below shows the marks obtained by the 40 pupils in a master's. Calculate the median of the distribution. We are given this table and we are asked to calculate the median. 0 to 9, 4, 10 to 19, 5, 20 to 29, 6, 30 to 50 to 59, 5. So we want to calculate the median. Now, the first thing you are going to do is to make your table. First one, make your the class. Look at this second column, which is boundary. In median, we always get the class boundaries. That means by adding 0.5 to this one, adding 0.5 to this one, these are the class boundary. Then we have the frequency table, and we have the cumulative frequency. I told you last class about this cumulative frequency. We repeat the first one. Second one, this is 4 plus 5, which is 9. Third one, the 3. You add these 3 together, it's give you 15. For this one, you have the 4. You add all these 4 together, you have this. This one, you have all the. So that's how you get this one, 40. And you can see that it said 40 in the question. So in median, you always get the class boundary and the cumulative frequency. You know, I told you last class too. The cumulative frequency is used in median mainly. But when you have a group data like this, you make sure that you get you don't need the class marker easily. You need the boundaries. Don't forget in the formula we are talking about the lower class boundary. You can see they are talking about boundary and cumulative frequency. You can see these are the two things we need under median. So whenever we have this, then let's look at the way it is being solved. Look at the median is L1. Don't forget L1 is the lower class boundary of the median class. Now let's look at what is even the median class. You can say that this is 40. There is 14 numbers of people. When you divide that 40 by 2, you have 20. So that means the 20th member is the median class. And when you look at this table, look at the 20th member will fall to be, this is 11, will fall to be here. That's what's the 20 because this is 9 plus 6. That will be 9 plus 6. That will be 15. 15. You can see this is 12. This is 27. So this 20 will fall around here. So this is the median class. So the median class is this. Let me try and indicate it. That is the median class. Excuse me. Let me just try and indicate the median class so that we can at least get something. This is the median class. That's the median class. Because 20 will actually fall in that range. That's where 20 will fall into. So the frequency of the median class is 12. So let's go. Now let we look at the median. So 20 lies in the cumulative frequency after 15. So the class interval is 30 to 39. That's just what I show you. So the lower class boundary of that class, which is the median class, 29.5. Look at that. Look at that. The lower class boundary, you can see lower class boundary is 29.5. This is the lower class boundary, 29.5. And the CFV, that is the frequency of the class before the median class. Look at the frequency of the class before the median class is 15. So we have the class interval to be 10. The class interval here of the class interval, because from 29.5 to 39.5, you have the class interval to be 10. So we then have what else? The frequency of the median class. The frequency of the median class to be 12. So then the median, and when we substitute all these values inside, we have the 29.5 plus 40 over 2 minus 15 over 12 and times 10. By the time you substitute and you get your value, the value gives you 36.67 in the median class. And if you want to get the median, you see that the median falls into the class. The answer we got here is 33.67, and you can see that 33.67 gets to the class we are talking about. The class is between 30 and 39. You can see that is also actually the median class, and that is actually the median actually. So look at this class interval. So the class activities is what I wanted to also look at this and do it together. This is also a why question. You have to find the median. Please try and practice this one and give me feedback if you have any problem with it. Now let's quickly look at there are two. Anyway, sorry, there are two activities I want to do there. We are calculating the median for this one. That's the first one, and that's a Y pass question. This is also the second one. You calculate the median of this distribution of 40 men in a village for me too as well. So the next one, let's quickly look at the mode for a group data. The mode for a group data, for a group data, mode is L1 plus the lambda, or the what do you call it, the lambda 1 over lambda 1 plus lambda 2 into C, or fx plus fx, L1 plus fs over fs plus fi into C. So L1 is also the class boundary of the model class. The triangle 1 or delta 1 or fx is the difference between the model frequency. There will be model class as well, because this is a group data, so there will be class. The frequency between the model frequency and the frequency next to the frequency lower next, that is the frequency of the class before the model class. The F2 or the lambda 2, or what do you call it, the 2 there is difference of the model class and the one after it, and CZ. So it just has lower class boundary of the model class plus frequency of the model class minus the one before it over frequency of the model class minus the one before it plus frequency of the model class minus the one after it. That's just the times the class interval. So let's look at this work example. This is the table given to us. We have to calculate the mode. And don't forget the mode class here. That's first you have to detect the mode class. The mode class here is 21 to 30, because that's one that have the highest frequency. Abi, you can see that the frequency there is 12, and that's the highest in the distribution. So now we go. What is the class boundary? We did the class boundary as well. The class boundary is this, and we have the frequency to be this. Then What is the model class? At like 21 to 30. Now I told you this is the model class, 21 to 30. That's the model class. So by the time you have this, then we have the class with the highest frequency. That's that out there. Now by the time we substitute formula, look at the model class is 31. Okay, now the lower class boundary of the model class is 20.5. You can get that from the table. The lower class boundary, let's look at that. Look at the lower class. This is the model class. This is the model class. So the lower class is 20.5. So the delta one is 12 minus 6. That is frequency of the model class minus the frequency of the class before it. Let's look at it. Frequency of the model class minus the 6. You can see minus frequency of the class before it, and this is frequency of the model class minus the one after it. So that is lambda 2. So lambda 1 is the frequency of the model class, so which is 6. Lambda 2 is the frequency of the model class minus the one after it, which is 11, which I show you in the table. So and 6 is the class boundary. Substitute this one into the formula. Class boundary is 10. That is from the from 20.5 to 30.5. That is 10 gap. When you subtract, that is 20.5, 21.5, 22.5, 20.5, 24.5 in that order. So by the time you substitute that one, you see that you get the value to be 29.07, just as that. So that's how that's it. So I want you to also do this why question as an activity. I want you to practice this question as an activity, and whenever you have any issue, please let me know if you have any problem in solving this. So I will be meeting you in our next class, and we shall be talking about some of the basic measurement of dispersion, all this range, standard deviation, and the likes. We shall be talking about complex situation. Thank you very much, and thanks for your attention. Try to stay safe. Regards to everyone. Thank you very much, and stay tuned. And please don't forget to subscribe to this channel so that anytime the video is being dropped inside for you, you will be notified. Subscribe to the channel A Plus Model Schools YouTube. Thank you very much.